student. So today we discuss what is the initial value problem on point 3 and how to find the solution of the initial value problems. Okay, so this is the last part of the chapter 1. Okay, so since that we will discuss application problem in chapter 3 and chapter 5. So we need to know what is the concept of the initial value problems, because any application you have must be written in terms of the initial value problem. Okay, so what is the initial value problem, IVP? So it's a problem that consists of a differential equation accompanied by a set of initial condition. Okay, so for example, if you are given a first order differential equation together with one initial condition, okay, y at x naught equal to y naught, this is the initial condition, then this set is called first order initial value problem. Okay, so the initial value problem must comes together with the initial condition. Okay, so this is the example of the first order initial value problem. Okay, the next example here is the second order initial value problem. Okay, let's see, you are given a second order differential equation together with the initial condition. Okay, there are two initial conditions here for this problem. Okay, y at x naught equal to y naught, and the second one is y prime at x naught equal to y1. Okay, so you look at here, the number of initial condition for the initial value problem will depends on the order of the differential equation. Okay, so this number of initial condition correspond to the order of the differential equation. If you are given third order differential equation, this equation must comes together with the three initial condition. Okay, otherwise we cannot solve the problem. Okay, if you are given fourth order, the number of initial condition must be 4 also. Okay, so the order, okay, the number of initial condition must correspond to the order of the initial value problem. Okay, and if you look at the initial value, the initial condition here, the initial condition are all set at the same point. Okay, x naught. Okay, so here you can see that this is the first initial condition. Okay, at x naught, and this is the second initial condition also at the same point x naught. So this is how to know whether this is the initial value problem or not. Okay, okay, let's see what is the solution of the initial value problem. Okay, okay, this is the general form of the IVP, the n order. Okay, of course, if you're given n order differential equation, okay, this equation must comes together with the n in number of initial condition. Okay, okay, let's see the solution. Okay, so for the solution for the IVP, okay, the final answer for the solution for the IVP must be a particular solution. Okay, if you still remember in the previous lecture 1.2, okay, we already defined what is the particular solution. Particular solution, it means that the solution without any parameter c. Okay, means that to get the final answer for the initial value problem, you must solve you must find the value for the parameter c. Okay, how to find the value for the parameter c? Okay, look at this example. Let's see, you are given the first order IVP, y prime equal to y square together with the one initial condition, y at 0 equal to -1. Okay, so let's see here, the general solution for this equation is given by this, y equal to -1 over x plus c. Since that I didn't discuss how to solve the differential equation yet, so for this topic, okay, we just give you the general solution first. Okay, later from chapter 2 and onwards, then we will try to find this kind of solution. Okay, so for this IVP, we need to find the c so that you will get the final answer for the IVP. Okay, so how to get the value for c? Just substitute the value by using the initial condition. Okay, the given initial condition here is y at 0 equal to -1, means that x equal to 0, the value of y equal to -1. Okay, so substitute the value of x and y here, then you will get the value of c. Okay, so now let's see here, this is the IVP. So this is your first condition, the initial condition. So we know that x equal to 0, y equal to -1. So substitute the value to find the c. So this is the given general solution. Okay, so when you substitute the value for x and y, you will get the value for c is equal to 1. Okay? So therefore, the solution for this first order IVP is given by y equal to negative 1 over x plus 1. So you have to substitute back the value for C into the given general solution, okay, to get the final answer for the IVP. Okay, okay. This is the example for the first order IVP. The next one is the example for the second order IVP. For now, I just focus on the first order IVP and the second order IVP because later in chapter 3, we will discuss the first order IVP. In chapter 5, the application will involve the second order IVP. So enough for you to know these two types of IVP. Okay, higher than that, okay, there are not so many applications which you use the higher than second order IVP. The first order IVP and the second order IVP very common in the application problem. Okay. Okay, now for this second order IVP, so you are given this differential equation. Okay, second order. Okay, and together with the two initial condition, you can hear the two initial condition here is located at the same point. Okay, x equal to 1, x equal to 1. Okay, of course, the first initial condition, y1 equal to 1 means that x equal to 1, y equal to 1. Okay, the second initial condition, x equal to 1, y prime equal to 0. Okay, so we need to find the solution for this IVP. Given the general solution for this equation is given by this C1x plus C2x ln x. Okay, later we will discuss how to find this kind of solution. Okay, so for now, you have to find the value for C1 and C2 by using these two initial condition. Okay, okay, now since that this is the second order, and then we have the second condition involve the y prime, so we need to calculate the first derivative for this y. Okay, so y equal to C1x plus C2x ln x. So find the first derivative for this. So differentiate the x, I get 1. So you get C1 here. And differentiate x ln x. This one you have to use the product rule. U equal to x, v equal to ln x. Okay, so according to the product rule, okay, x differentiate ln x, I get 1 over x. So 1 over x times x, I get 1 here. Okay, and then plus ln x differentiate x, I get, okay, only ln x. Okay, the C2 put outside because this is a constant. Okay, so this is the y prime. So after you get the first derivative, so calculate the C1 and C2. Okay, so by using the first initial condition, the y1 equal to 1 means that x equal to 1, y equal to 1. So substitute into the equation y equal to this, okay, the first one here. So after you substitute the value, you will get your C1 equal to 1 because the ln 1 here is 0. So everything here will be 0. So you get the value for C1. Okay, and to get the C2, okay, by using the second initial condition, y prime at 1 equal to 0. So here you substitute the value x equal to 1, y prime equal to 0 by using this equation. So after you substitute the value, okay, again the ln 1 equal to 0. So you will get C1 plus C2 here equal to 0. Okay, and then solve for C2. C2 equal to negative C1. And since that the C1 already get the value here, which is 1, so the C2 equal to negative 1. Okay, so the final answer for this IVP is y equal to, put back the value C1 and C2 here that you obtained from here. Okay, so C1 equal to 1, so you get x here. C2 equal to negative 1, so I get negative x ln x. Okay, so this is how to find the solution for the IVP. Okay, just substitute the value, the value from the initial condition given here to get the value for the parameter, so that you'll get the final answer for the IVP.